Hello everyone, I am Shreyas and this is my teammate Goutham Kalla. Our project is traffic accident analysis. So according to US Department of Transportation, over 6.1 million road accidents occurred in 2021 alone, resulting in more than 42,000 fatalities. This highlights the importance of identifying when, where and why these accidents happen. This is the core question of our problem statement. Answer to this question, we'll answer this questions using our visualization in later parts of this presentation. Coming to our dataset, we used a publicly available traffic dataset with 7 plus million records from 2016 to 2023 covering over 50 states in the United States of America. We did sample data. So to manage scale and maintain statistical integrity, we used ratio-based sampling that preserves the distribution and intensity of accidents using machine learning techniques. Backend we built it with Flask. Frontend we developed using React.js framework. For maps we used US Atlas dependency, and for visualization we used d3.js. Let me walk through our dashboard. Firstly, we have our choropleth map. This US map displays state-wise distribution of accident distribution. You can clearly see there is the difference in intensities. So we use this map for geospatial comparison at a glance. So the darker shades indicates more accidents. Clearly we can see that in California we have more accidents, followed by Texas and Florida. We used this is an interactive map, so you can zoom in. So if we zoom in, we can have in the viewpoint we have 15 states visible. So the dashboard re-renders to the 15 state data, and then you can go back. We can also select a state and the dashboard will re-render to its data. We have selected California for now. We can also select different states. This is a crash collision data density data, and the data points have different integrities. The darker shade indicates more severe accident and lighter shade indicates less severe accident. And if there is multiple collisions at a single point, then we use a larger circle to represent that data. We can see different states. For example, we'll select Texas now, and here we have the same thing for Texas, and the dashboard represents Texas data. Coming to our next map. So here it indicates the top, this is a squarified tree map. It indicates the top 10 counties where most number of accidents happen. If you select a state, and then it will re-render to top 10 counties of its state. For example, I've selected California, and then here are the top 10 California counties that have where more accidents happen. And this is a sunburst chart of top 10 zip codes where most number of accidents happen. So, so clearly we can see here Los Angeles has the highest, and then we can go to the next is seasonal patterns. This is again a sunburst diagram. So first in California we can see in winter there are most number of accidents, and then in winter we can see here the month of Jan has most number of accidents. Now we will reset the state. So now this is for the whole US. Similarly, we have seen the winter has more number of accidents, and the month of Jan there are more number of accidents, and I think the fall is the least. So here it helps us to connect accident rates to weather and travel behavior. Next we have point of interest analysis. It is a radial bar chart showing most accidents occur, why most accidents occur, and we can clearly see that in crossings we have most number of accidents in America, and then followed by junctions. We can select a state and see why most number of accidents happen in that particular state. In even Texas, we have crossing the number one and junction number two. We can use a different state, maybe California. California's junctions is in California junction is number one and crossing is number two, and followed by stop. Uh, we can also select New York, maybe a different state, the state we live in. Here also the junctions there are more number of accidents, and Westchester County has more number of accidents. Collision distribution. So I think now my teammate Goutham will continue the rest of the dashboard.
Thank you, Shreyas. Let me go through the time and weekday analysis. It is a component of two diagrams. One is the line chart, and another is the heat map. The line chart, displays the hourly accident trends, and the heat map displays the frequency of the accidents with respect to the day of the week. We can clearly observe there are two spikes at between 7 to 8 a.m. and 4 to 5 p.m. which align with the rush hours where we commute from work or to work. Now we can also brush this time range. Let me select a range. It is like from 5 a.m. to 11 a.m. Now the corresponding filter has been activated, and the corresponding component re-renders across all the components of our dashboard. Now these are the number of accidents that occurred between 5 to 11. 56 of those were at junction, and followed by 48 at crossings. In the same way, 31% of the accidents in between 5 to 12 a.m. occurred in winter, but here the metric changes. Now, the December has the highest number of accidents during that time period, and this heat map represents at what times the more accidents occur. That we can see the difference in intensities. The more the intensity, the more number of accidents. We can clearly observe that there is a um, more number of accidents during Tuesdays at a time between 5 to 6 p.m. and more number of accidents during Monday morning 5 to 7 a.m. We use a line chart for the time because it is a best representation for the series time series visualization, and we use a heat map because it combines both week of the day and the time of the day interactions, which makes our analysis more for easier. Now let me reset my filters, and let me reset my state as well. Now coming to the weather influence on accidents. There is a PCP plot for me between all the weather components, weather related variables like temperature, humidity, visibility, wind speed, and precipitation. Now they were mapped with the severity of the accidents. These plots can be rearranged. Now the visibility came at the end. These are also can be brushed. Let me select a low visibility area and medium humid. Now we can see the brush data, and this is the whole filter data according to this weather conditions and the severity. Let me reset this filter as well. Now, so let me come to the insights that we can draw from our dashboard. Uh, We can also those are like which is the highest day of accidents. Let's say from this diagram we can say that it might be like Tuesday and Friday. Coming to the peak hours where more number of accidents occur, that might be like 5 a.m. to 8 a.m. and 4 p.m. to 7 p.m. Coming to most number of accidents that occur in California state and Los Angeles County, and these are the top 10 pin codes. And coming to the seasonal analysis, on which in which season most number of accidents occur, it is winter. Coming to the weather influence, we can see that more high severity accidents occur due to low visibility and high humidity. These are the some of the insights we can draw. Now every chart is linked when a user selects any of the data, all the components re-render and visuals update in real time. This makes our dashboard more interactive and powerful for policymakers and analysts. There is one more feature to our dashboard. There's a traffic signal head over here, which is like containing red, yellow, and green. These can be used to switch the theme of our dashboard. Now it's in red color, so it's in red theme. Let me switch to green. Then the color palette switches to green, and let me select yellow. Again, the color palette switches to yellow. Let me switch back to red. And overall our dashboard provides data backed insights that can inform smarter information and help us plan infrastructure and weather specific advisory steps that we can take.